Welcome everyone to another Leetcode problem discussion. Today's problem is problem 238, product of array except self. And this is one of the problems within the blind 75 list. So let's go to the problem description. We're given an integer array, as you can see. We have to return an array answer. So such that every value in the return array is equal to the product of all elements of the input array except the element at that particular index. Okay. And you must write an algorithm to runs in order of n time and without using the division operation. Okay, so here's the thing. So as you can see here, for the first example, this is our input array 1, 2, 3, 4. So, and this is our output. So that means for the first output is such that it's the product of all the values except the value in that same index. So it would be 2, 3, and 4. Like that is 6 and 24. Okay. So suppose for the third index, so it's going to be the answer for the third index is going to be you except the third value, we have to take the product of other values. So 1 into 2 into 4, that is 8. Okay. So how can we do this? Well, at the beginning, it doesn't seem to be like very challenging. This is a medium problem because actually, although it looks a little bit like easy, there we have to put some thought in it. So first of all, the easiest way to think about it, the naive way, right? So we can just go through the input, and what we can do is when we are actually at the first index, we just read through the whole array and just multiply them. So 2 into 3 into 4, right? 2 into 3 into 4 equals to 24, right? So we put that value in index 1. So we keep on doing this for each of them. For suppose when we are actually doing the third index, for the third index, what we do is we just leave this and then keep on multiplying 1 into 2 into 4. That is 8, right? Okay. But the thing is, if we are doing this, this is going to be for, you see, for each index, we are actually multiplying all the others. So that's, we are reading n values. So for each index, we are doing order of n operation, and we are doing it for n indices, right? So overall, it's going to be order of n squared. But we don't want a order of n squared. As we said, like the algorithm should be in order of n. Okay. So that means this is not a good algorithm. We don't want this. So how can we do this? Well, the next clever technique is, I think, is already in your mind. The thing is, why don't we just multiply it everything? So 1 into 2 is 2, 1 into 2 is 6, and then 24, right? So we first save this value, the whole multiplied thing, and then we know that for each index, that for the answer, right, we have to just leave that value of that index. So for the first one, it would be 24 divided by 1, right? Because we have to leave 1. So that would be 24. We know that the 4 elements, the multiplication of the 4 elements, the value is 24. So we divide just by that index. That means it gives you the value for all the multiplied numbers except that number, right? For the second index, we can say, okay, 24 divided by 2, right? So it means that I am multiplying 1, 3, and 4, right? So it will be 12. Okay, so this thing, like this multiplication takes like order of n, first multiplying it, and then when you're actually producing the answers, every time we are just taking this value and dividing it. So for one operation here, one operation here, so it's order of n operations to get the answer. So although this looks like an order of n operation, is still this is not accepted because we cannot do division. Okay, so we got a order of n solution, but we still couldn't do a division. Okay, so how do we do it? Okay, so let's think about another technique. So as you can see, when we are actually saying, say, for this value, right? It's actually multiplication of this part and this part, right? So the right side and the left side. Okay, so if we can do some pre-processing to get the multiplied partial results for the right side and left side, basically this can do our trick, right? So why don't we do this? So let's say this is our input, and then this is, say, our left multiplication, and this is our right side value. And then let's see what we can do with this. Okay, so first, let's say from the left, -1, then -1 into 7 is -7, then -21, so -105, right? And then 9, so 945, and 1890, right? Okay, so each of these values gives us the multiplied values all the way from the left, right? Okay, now let's do the same thing from the right. So if we just take this, is the multiplied value is 2. 2 and -9 is -18, and then -90, right? -270. Okay, and this is -1890. Sorry, yeah, this is -1890, and finally 1890, right? So this is from the right. Okay, now let's see if we, so this is our, so this one took order of n time. This one also took order of n time to calculate, right? And so every time what I was doing is I was just multiplying one value. So let's see, this is our answer, right? So for the answer, let's see how can we find this answer. So can we say that this answer is actually a multiplication of, say, this portion along with this portion, right? So basically, oh, okay, not this portion actually. I'm just making mistake. So it will be, if I want to leave this index, if I want to leave this, so this is the multiplication of this is here, right? And the multiplication of this part, the right side, is actually captured here, right? So the answer here is -21 into -18, right? That's the answer here. So we can actually find all the values here by doing that. And for like pre-processing thing, let's put an additional 1 here at the left and additional 1 at the right. That will actually help us, because when we are trying to find this value, right? Sorry. Basically, what we'll be doing is from the left, sorry, this is 9.5. From the left, we'll take this. And from the right, we'll take this, right? So we'll multiply these two. Okay. Similarly, when you are actually calculating this value, from the left, we are going to take this. So sorry, from the right, we're going to take this, and from the left, we're going to take this. Okay. So this is also simple. Just for each position, we have to multiply two values, one from this array and one from this array. Okay. So this is going to be order of n. So now we got an amazing order of n algorithm without using any division operator. We just are doing multiplication. The only trade-off is here we are using some space. So, so this was the time complexity. And the space complexity is going to be, as you can see, we keep an extra array of order of n here, order of n here. This one we don't consider as the extra space because the result array is not considered as an extra space. We need it. So this space is also order of n. Okay. Yeah. So there goes our order of n algorithm with trade-off is order of n space. Now, as you can see, there is a follow-up. Can you solve this problem in order of n? With order of 1 constant extra space, and the output array does not count as extra space for space complexity. Okay, so yes, probably we can do that. Why don't we use the answer? So let's say this is the answer, right? So let's fill up the answer with the left multiplication first. So -1, and then -1 into 7 is -7, -7 into 3 is -21, -105, -945. Sorry, this is plus 945 because this is negative. And finally 1890, right? So we took the left multiplications. Now let's see. Actually, here, what do I want here? Basically, I want everything from the left, right? Everything from the left is here, right? This into everything from the right. Can we do that? Yep. Okay. So first we calculate this. This is order of n. We calculate everything from the left, like we calculate all the multiplied values from the left. Now let's fill this up. Let's put an extra 1 here, just for the sake of calculation, right? Now we want to replace this by everything from the left is captured here into this. Okay, so can we say, so that value is 945, right? Okay, there goes it. Now next value, we want to replace this. Now this one would be like this into whatever is in the right. That means whatever is here, right? Okay, so let's keep a right thing. Let's keep track of the right thing. And as we can see, the right was initially 1. So it's 1 into 2. Right is 2, right? Okay, so 105 into right is 2. So this is right. This is 2. Right multiplication, right? So it's going to be minus 210, right? Okay. And now the right becomes 2 into -9. That means right multiplication becomes -18. So this one actually represents everything that is here, right? Everything that is here. Represents everything here. And now we want to replace this one. Now this one is going to be everything here, that is this, into this portion, right? This one captures everything here. Okay, so it would be -21 into -18, right? And that thing goes here. So we replace this, and we actually never need this. Next, we just want the next right value to capture everything here, right? So what is that? -18 into 5. So right is now going to be -90. And everything here, that is -7, right? So next, here goes -7 into -90. Okay, so basically we're using the same output array, reusing it, and then first filling up from the left And then using that value and also keep on calculating the right multiplied thing in a variable and using that to fill up the output array, right? So as you can see, we're not using any extra space and it's being done in order of n. Okay. Okay. So yeah. So it's going to be minus 90 into minus 7. So this is going to be minus 630, right? Okay, 630. Okay, next, if I want to fill this one up, it will be minus 1 into 90. Now right becomes all these, right? So it will be minus 270. That means minus 270 into minus 1, that is 270. Okay, and next minus 270, this one now right includes this into 7, and let's put a left 1 in the left, or what we can do is once we reach here, I can just keep only take only the right. So this is going to be minus 270 into 7. Got it? Okay, so that's it. Let's go and check the code. So let's just check the code. The code is very simple. I just take an answer array of size, the same size with the input array. And as for the ease of the calculation, we take a left product of 1. We initialize with 1. Then we read from left all the way to the end of the input and multiply the current value with the current left product and put it in that particular index of the answer array. So that's the first part of the pre-processing. And then we start from the right. So we start with right product with 1, and then we replace the answer with the right product multiplied by the previous value in the answer array. That one captures the left product, right? Okay, and then we update the right product with what? The current right product with the current array element, right? Okay, and next time we will be using this right product in the next iteration of the for loop. And finally, when we reach the last index, so we are doing this from the right to left, and for the last element, we are just taking the right product, just the way I explained to you. And finally, we are returning the answer array. So that way we are doing it in order of n, but without any extra memory, just the answer array, that's it. So I hope you enjoyed the explanation, and thank you very much for watching. We'll come back with another problem next time.